Hello everyone, welcome to Jagametrics, where we discuss econometrics for development studies. In the last lecture we discussed the stationarity of variables in choosing the appropriate estimation technique for regression analysis. It is important to know that the regression of a non-stationary time series on another non-stationary time series may produce a nonsense or spurious regression. In order to avoid spurious regression results, this lecture discusses a long-term dynamic concept called cointegration. Now, what is cointegration? Cointegration identifies long-term equilibrium relationships between variables that are stationary at first difference or integrated of order 1, that is I1. Economically speaking, two variables will be cointegrated if they have a long-term or equilibrium relationship between them. And there are two methods for identifying long-term equilibrium relationships. The first one is Igor-Granger two-step method, which is designed for two variable case. We also have the Johansen Cointegration for multivariate systems, which is designed for more than two variables. For this study, we are going to consider the Johansen Cointegration for two reasons. One is that most econometric models are models with more than two variables, and two, it ensures robustness in multivariate systems. The EVIEWS software package will be used to demonstrate the Johansen Cointegration. In order to carry out the Johansen Cointegration test, there are steps that must be followed. The first one is to import data to EVIEWS. Now, this has been demonstrated in our first video posted on the 22nd of March 2025. You can go through that video and see how we import data from Excel to EVIEWS. And the second step is that the variables must be stationary at first difference or integrated of order 1 using the ADF, that's augmented Dickey-Fuller, or the Phillips-Perron test, or the both of them. Now, we have also demonstrated how to carry out stationarity test using the ADF and the Phillips-Perron tests in the video posted on 23 March 2025. So with this in mind, we would like to go through the practical session using EVIEWS. Now we look at our work file. We see we have data on GDP. We also have data on population and data on government revenue. Data on GDP, data on population, and data on government revenue. So in order for us to do a Johansen Cointegration test, we have to first of all test to make sure that the variables are stationary at first difference. Okay, we click on GDP. Let me click on view. We go to our unit root test. We click on standard unit root test. Then let's check the ADF test at level. Press OK. Okay, the probability of 0.4503 shows that GDP is not stationary at level. So let us go and check the stationarity of GDP at first difference. Okay, at first difference, click OK. Yes, the probability value of 0.0398 shows is less than 0.05. It shows that GDP is stationary at first difference. Okay, we'll now move to the next variable. We close this, we go to population variable on the population. Okay, click on view, go to unit root test, the standard unit root test, then we click on level, and then we click OK. You see probability of 0.9994 shows that the variable population is not stationary at levels. We will now go and test for stationarity at first difference. Okay, first difference, press OK. Yes, so guys, you can see probability value of 0.0101 is less than 0.05, which shows that population, the variable population, is stationary at first difference. Okay, this is good. And then we'll now go to ascertain that of government revenue. Okay, click on view, unit root test, standard unit root test, click on level, let's check. Okay, probability value of 0.7587 is greater than 0.05, hence government revenue is not stationary at levels. Okay, let us go and see the stationarity of government revenue at first difference. Okay, first difference, you click OK. Yes, the probability value is less than 0.05, it is 0.0034. You can conclude that the variable or the time series government revenue is stationary at first difference. Having ascertained that GDP, ascertained the fact that GDP, population, and government revenue are stationary at first difference, then we can now check for long-term equilibrium relationship among them. Okay, we'll now click on quick. We'll go to group statistics. We click on Johansen Cointegration test. Okay, we click on we type GDP, then we government revenue and population. Okay, let's have we see if they are co-integrated. You press OK. You see lag intervals of indigenous variable 1 and 1. We leave that space like that. You see where we have Mackinnon, Hooge, Michaelis, the size 0.05, it's okay. And then we leave everything, we maintain the status quo. Then we click OK. Now on clicking OK, let me enlarge this file. Yes, on clicking OK, we now have the summary of our Johansen Cointegration test. We also have the rank tests. Now it is the rank test that tells us if the variables have long-run equilibrium relationship, or if long-run relationship exists among GDP, government revenue, and population. Okay, now the rank test shows that the trace tests indicate one co-integrated equations at the 0.05 level. This shows that at the trace test, the three variables are co-integrated. We now go to the max engine value rank test. You can see here we have just one asterisk, shows max engine value test indicates one co-integration or one co-integrating equation at the 0.05 level. So with this co-integration result, we can rightly say that long-run relationship exists among GDP, government revenue, and population. So that is, thank you very much for participating in today's class. Maybe till some other time when we shall discuss on other techniques.